Now, as promised, here we go with talking about circle graphs. Question number 2 says the circle graph shows the results of a survey about favorite types of muffins. Find the central angle measure of the sector that shows the percent of people whose favorite type of muffin is blueberry. So you can see here is your circle graph, and we're supposed to figure out the measure of the central angle for the sector for blueberry, which is this darkest one. That's this one up here on the right side of the circle graph. So let's see what they're talking about here. All right, the answer is the measure of the central angle that represents blueberry. And then they're going to list the important information. The percent of people whose favorite muffin is blueberry is 40%. The central angle measure of the sector that represents this group is 40% of the 360-degree circle. Probably time for a little bit of explanation here. Okay, a couple different things here pop up that we can talk about here, including definitions. You've got the idea of a central angle here. A central angle is an angle that's simply formed by two radii of a circle. Obviously here in this illustration you've got lots of different options here, but there's 4 that happen to be highlighted by the circle graph. You've got this angle in here being formed by these two radii that make up the 10% sector. You've got this angle here in this light gray sector being formed by this 15% sector. You've got this angle down here in the 35% sector being formed by these two radii. And then you've got this big one in the blueberry one, which is the one we care about, being formed by these two radii. Now, of course, some of us might only be looking for the obvious answers here, but we can talk about other angles. For instance, if we wanted to put these two guys together, we could be talking about the angle formed by the two radii that go north and west here. All right, there's lots of different options in reality here. The only one we really are concerned with, though, is this angle here on the right side. Now, each one of these parts of a circle graph hits the other definition that they gave us there called a sector. Now, what they want to know is how big, in terms of degrees, this 40% sector is that represents blueberry. Well, the way we do that is we use the fact that the angles of a circle measure 360 degrees. If I add up the angles going around this way, all of them together, they have to add up to make 360 degrees. Since we know every circle is 360 degrees no matter what, and we know that this sector that represents blueberry is 40% of that 360 degrees, what they're telling us to do here is to find 40% of 360, or in other words, multiply together 40% and 360, which is what you can see they told us to do right here in step 1. Alright, so as we scroll down here and take a look at step 2, step 2 tells us there's 360 degrees in a circle again, and since the sector is 40% of the circle graph, one of our favorite keywords in 7th grade math, the central angle is 40% of the 360 degrees in the circle. So I'm going to multiply together 40% and 360. And when I do that, I end up with a solution of 144. Meaning the central angle must measure 144 degrees. Obviously that makes sense. Why does it make sense? Well, it's less than half of the graph. Half of the graph would be half of 360, or in other words 180. It is just a little bit less than 180, so our answer is logical. Alright, so let's go ahead and go to the bottom of the page here and take a look at the check it out example. In this example here, they're asking us to name the diameters of circle G. So remember, a diameter goes all the way across the circle and through the middle. If it just happens to go from point on the curve to point on the curve, but not necessarily through the middle, that's a chord. But the ones that go through the middle, those are called diameters. So I see I've got this one that kind of runs up down here. Starts at B, runs through our middle G, that's important, and ends here at F. So as you can see, they've named BF as one of the diameters. And then you've got this one that runs across the page from left to right here. That one's called AD. Again, goes through G, that's important because it has to. You could name it the other way, DA. So BF and AD are the diameters of circle G.